Hi guys, welcome back. Still in chapter 15. We're covering sections 3 and 5 today, so feel free to follow along in your book as we go through this, okay? A lot to cover, so let's get to it. Talking about winds. Winds are something we experience all the time, a light breeze to a heavy gust. They are defined simply as the horizontal movement of air, but it's always from an area of high pressure to low pressure. So if you haven't watched it already, watch the video that I did on air pressure, okay? It's really important to understand that concept of air pressure always wanting to move from a higher pressure area to a lower pressure area, okay? If you don't have that concept down, this idea of winds it's going to be a little difficult, okay? Always moving from high to low. They're caused by those differences in the air pressure. If the air pressure is stable, then it's not windy. It's as simple as that. If there is wind or breeze, it means that there's a different air pressure, and the high is going to low. This funky looking instrument over there that looks like it's got these like tennis balls cut in half on it, that's an anemometer, and that's actually used to measure wind speed. Okay, so this portion of it, this guy, that's just a weather vane or a wind vane. That helps determine the direction that the wind is coming from. But these guys up here, those are catching the wind and they're spinning, and they're used to determine how fast the wind is blowing. Okay? We also have this thing known as the wind chill factor, and that's not something that affects us in the area that we live very much. Our temperatures are pretty stable. But in areas where there's a lot of snowstorms, that wind can actually cause the temperature to drop even more than just the typical air temperature, okay? And you have experienced this. If you get out of a pool in the summer, you know it's warm, you can feel the sun. If a breeze hits you, it cools you down, okay? So that wind chill is actually something that cools you off despite the air temperature, okay? All right, now let's talk about local winds. These are winds that are happening in areas of land close to water, okay? So like coastal regions on a large lake or by an ocean, okay? Local meaning it's a smaller area, okay? They are caused by uneven heating and cooling of the Earth's surface, okay? So what happens is dirt, the land, actually heats up a lot faster than water does. And you've noticed this. If you go to the beach, the sand feels hot. You go into the water feels cold, okay? Well, while the land heats up faster, it also cools off faster. So it takes a lot longer to heat up water, but then it takes the water a lot longer to lose that heat. So because of that uneven heating and cooling of those two different surfaces, we get these things known as local winds, okay? So let's talk about a sea breeze first, okay? And that's this diagram right here. So during the day, the land heats up a lot faster, and so the air above the land becomes warmer, and warm air rises, okay? Well, when it's rising, it's spreading out. That's why it's rising. It's becoming less dense, it's spreading out. So there's actually much lower pressure, okay? Well, then that cooler air over the water has a higher pressure. It's more dense, has a higher pressure, so that air over the water blows into the land, okay? That's known as a sea breeze, and that happens during the day. And you've experienced this being at the beach. The wind tends to blow in from the ocean, okay? Well, at night, we get what's known as a land breeze. Now we're on to letter B right here, okay? And the exact opposite happens. So the sun is down, so nothing is being heated, but now we're talking about how quickly these things are cooling, okay? The land is going to cool a lot quicker than the water, okay? So while the water is cooling slowly, that means the air above the water now is warmer than the air above the land, because the land cools so much more quickly. So the warmer air above the water is less dense, it rises, it's lower pressure. The cooler air above the land is more dense, it's higher pressure, so now the breeze moves, the wind moves from the land to the water, and that's known as a land breeze, okay? Definitely you're going to need to understand those two different types of local winds. They're described really well in the book as well. Then we get to something called a monsoon. And a monsoon is kind of like those local winds, but on a much larger scale, okay? Much bigger area. This picture right here is not a nuclear explosion. It's actually a storm, and this is rain lots of rain dropping down like that, okay? These monsoons follow seasonal patterns, not just daily patterns. So, during the summer, the heating and cooling is taking place over like a continent even, from an ocean, and it's taking months at a time, okay? Again, during the summer, the wind will bring in warm, humid air from the ocean, brings it over the land, which is cooler, and so it cools off. And when it cools off, that moisture in the air is going to turn into rain, a lot of rain. We're going to learn more about that process of the water vapor becoming rain in the next lecture. Okay, so stay tuned for that. All right. So in addition to these global or local winds, we have what's known as global winds, and it's also due to uneven heating and cooling, but it's over the entire planet now. This is happening up in the atmosphere, okay? And you're getting these pockets of convection currents, okay? You're getting this movement of hot air rises, cooler air sinks, and they're trading places constantly. And that's happening down in that lower level of the troposphere, okay? The warmest areas of the globe are the equator, closer to the equator, and the cooler areas are the poles, the North and the South Pole, okay? But you also get this kind of this 30-degree latitude line that's kind of in between, okay? So the hottest areas over the equator, that hot air is rising, okay? And then it gets blown up or down, okay, both, but it can't reach it all the way to the pole before it cools off. It actually starts cooling off right about that 30-degree latitude, and so then it drops, okay? But at this 30-degree latitude, north and south, it's still a lot warmer than the poles, so you're getting that effect to a smaller level, okay? I don't really want you to worry about these global winds much more than that. I'm not going to test you a lot on the specifics of it, okay? But in addition to these pockets of the convection currents, you get these arrows. You see how these arrows are all curved at different angles? And actually, if you look at page 485 in your book, there's another diagram of this. Well, the wind is blowing, okay? So the air is moving. Let's say it's starting at the equator, right? And it starts blowing up towards the North Pole. Well, what's happening to the Earth? It's rotating, okay? So the wind is actually going off at an angle because of that rotation of the Earth. So that curvature of the wind due to the rotation of the Earth is known as the Coriolis effect, okay? Be familiar with that. Now, this isn't demonstrated on this diagram right here, but the jet stream is another large pocket of wind, okay? It's very fast-moving air, and it's also caused by this uneven heating and cooling. But jets actually rely on this. There are different streams that move over the United States and over other continents, and it moves in different directions. And so these jets try to get into the jet stream because it's easier to fly. They get better gas mileage when they fly in these jet streams. They're just regular currents of air that are moving really quickly because of that uneven heating and cooling. Crazy. All right, now let's talk about precipitation. Precipitation is basically just any form of water that falls from a cloud and hits the ground, okay? We typically only get rain here in Southern California, okay? But there's lots of other types of precipitation. The definition of rain is that it's a water droplet that has to be at least 1/2 millimeter wide, okay? If it's smaller than that, then we refer to it as either mist or drizzle, okay? But for the most part, we're talking about rain. If it's big enough to fall, it's rain, and that means it's at least 1/2 millimeter. Well, we can also experience freezing rain in really, really cold environments, okay? And freezing rain is still liquid water that falls, but when it hits the ground, it freezes solid, okay? And then we have sleet and hail, which are both frozen droplets of rain. They're just different sizes, okay? Sleet is if the drop of frozen rain, so a little tiny piece of ice, is smaller than 1/2 millimeter, and it's called hail if it's larger than 1/2 millimeter, okay? Now, this right here is clearly larger than 1/2 millimeter. Sometimes we get these crazy storms, not out here, but in Texas and in the Midwest. They get these crazy storms that those hail pieces can get up to like baseball size, and they cause all kinds of damage. We'll learn more about the formation of hail when we start talking about severe weather patterns in a later chapter, okay? And then finally, that leaves us with snow. Snow is simply water vapor, so the gaseous form of water that turned directly into an ice crystal. It didn't freeze into, or it didn't condense into liquid water first. It just went straight from gas to an ice crystal. And the snowflakes form these really pretty patterns because they're a crystallized version of ice. And those are all different examples of precipitation. And that brings us to the end of our lecture. See you guys later.